Okay, so we are going to do the homework problems from lessons 3-6, right? So I'll just write down section, oh, purple, 3-6. And we're, yeah, might not look like it on the screen, but it is. Okay. What are we doing? 18 first, right? All right, let's take a look at it. It says line L contains these points, 4, -1, and 4, 9. All right, and point P is at 1, 6. So I'll put a P and I'll put 1, 6. Oh, let's do this. Let's put some graph marks on here if I remember how to do that. It's boom, look at that, like magic. Isn't that cool?
That's cool.
It is cool. Do I have enough room though? Can I go to 9? 4, 9. Yeah, I'll make it a little lower because I don't have to go so high. So let's make the x-axis right here. Is that all right? And then, or the x-axis. Let's right there. We go. And how far down we're going? That's good enough. So that should cover everything, shouldn't it? Let's make it in red. All right. So 4, -1. 1, 2, 3. Let's see. 1, 2, 3, 4, -1. Right there. And I'll write the point in. And then 4, 9. So it's 1, 2, 3, 4, 5, 6, 7, 8, way up here. 4, 9. And then let's do this. That's a line segment, isn't it? Or a line. And so we're going to connect it like that. Oh, why did I make that red? Let's make that black again. There we go. All right, now that point that's not on the line is 1, 6. And we'll make this, we made this blue yesterday, didn't we? Or no, we were going to, but my projector went bad on me. So 1, 6. 1, 1, 2, 3, 4, 5, 6. Right. Is that 6? Did I count correctly? All right. All right, there we go. Wow, this is actually a really easy one. So this is what you're talking about as far as the point. Yeah, you know what I would do? I would exactly do that. I wouldn't even bother putting in the numbers and stuff because this is, I mean, there's, you know, you're going to be right on, aren't you, on this? Yeah, because you got horizontal and you got vertical, because this is a vertical line, so the perpendicular is going to be horizontal, isn't it? Okay, so I could find that point exactly. I know. So I don't even have to put the numbers in on this one. So what is it? It's 4, what? 1, 2, 3, 4, 5, 6. Okay, so that's 4, 6. And now all I got to do is find the distance between them, so I just throw it into the distance formula. So this one was pretty nice and easy. Agree? So what do we got? Yeah, shoot. Yeah, you need the distance formula. What am I thinking? I'm thinking, yeah, I'm making it harder than I really wasn't. I don't know why I was doing that. Yeah, you can just count. It's just a cross, so 1, 2, 3. So the distance is 3, and you're done. There you go. Yep, I don't know why I was going through that. I don't know. It's just force of habit, But yeah, you can just count since if it's vertical, if your distance is vertical or horizontal, sure, you can just count. As long as you know that it lies right on the point. If it's in between somewhere, it may not be so easy. But yeah, that's it. Well, that was easy. Let's do number 19. Somebody in the other class said 19 was hard. Did you find 19 to be difficult or not? 16 had a lot of crazy fractions on it.
16, I couldn't get it. It's like
Yeah.
37.
Oh, you know what? 16 is not. You know what? The problems that I did in the other class aren't on the computer anyway, so I will have to do 16 because my computer rebooted because it downloaded new thingies, whatever you call it. What do you call them? Yeah, some updates and stuff. And then I'm in the middle of doing stuff, and everything's shutting down on me. I'm like, what's going on? What's going on? And I was like, oh, I can't believe it. So I went to the board and I did it on the board. So it's not on YouTube. So you're gonna have. So we'll do that one. So let's do. You want to do 16 or do 19? Let's do 19. I promised the girl in the other class we'll do 19, and if we have time, we'll do 16. Okay. All right. Here's our situation. We got 2 points that form that line, and then we got this point that's not on this line right here. So let's plot these points. It's 1, 5. 1, 1, 2, 3, 4, 5. And then it's 4, -4. 1, 2, 3, 4. 1, 2, 3, 4. Let's connect them. Alright, and let's put the points next to it. And this is 4, negative 4. Alright, the point that's not on here, let's do that in a different color again. Let's go stick with the blue. It's a nice color. Negative 1, 1. Negative 1, 1. Right there. Alright, so what do we have to do? We've got to find the distance between this point and this red line. So I draw it. How do I draw it? Do I draw it to here? To here? Where do I draw it? Perpendicular, right. So it's going to be in there somewhere. Where do you think? Do you think it's there? Probably. My guess is it's probably there, but I'm not sure. Okay. Because I just eyeballed it, right? I mean, I didn't do really anything in particular to make sure that it was perpendicular. So, so there you go. And what is this point? This is negative 1, 1. So what am I trying to do? My goal really is to find that point right there. If I can find this point, right, then I can find the distance between those 2 points. And then I got the distance of that line. You got it? So first thing we do is, let's do this in red. First thing we're going to do is find the equation of both lines. All right, that's our first step. It's a long step. You got to do a couple things, several things to get it. But our first step is to find the equation of the 2 lines. Let's do that over here. So let's find the equation of the red line, and I'll do this in red. So it's y equals mx plus b. That's what we want to do for the red line. So first thing we do is find the slope. You could just count if you wanted to from here to here, or you could use the formula. Let's use the formula. It's good to know it. Okay, so the formula is a change in y over the change in x, so you subtract the y's. 5 minus negative 4, which will be plus 4, and then 1 minus 4. Right? That's 9 over what? Negative 3, so my slope is negative 3. So that's my slope. Now I can find my y-intercept by putting in an x and a y. I can either pick this point or this one right here. It doesn't matter. Any point on this line I can put in for x and y, and I can get the y-intercept. So let's just use the first one. So I'll see what I'm putting it into. I'm putting it into y equals mx plus b. So y equals m, which is just found, negative 3, times x, which is this point right here, right? I'm picking this point. Agreed? So I picked the 1 plus b. This works out nice and easy because we've got nice integer numbers. So 5 equals negative 3 plus b. What's b? It's 8. All right? That makes sense, doesn't it? Because if it kept on going, it would go up here, and sure, it would be up here around 8, wouldn't it? All right, so let's write my equation down. That's my whole deal. I want to find the equation of this red line. So it's y equals what? Negative 3x plus 8. Good. Put that in a box. We'll keep it there for safekeeping until we're done, all right? Until we need it. Now let's go do the same thing for which one? For the other one, for the other line, this blue one right here. So let's do this in blue. Can I fit it in here? So first of all, the slope of the red one was negative 3. So what's the slope of the blue one going to be? It's going to be positive, what? 1/3. So that was easy, right, to find the slope. Hardly any math at all. Just flip the fraction, change the sign, and I'm good to go. Now, I know a point on this blue line. I know one point on there. What is it? It's negative 1, 1. So I can take this point and this slope and find the equation of the line. So let's do that. I like to write y equals mx plus b just to make sure I know what I'm supposed to be putting in. So put in the y. What is the y for this point? So 1 equals m, which is 1/3, times x, which is negative 1, plus b. 1 equals negative 1/3 plus b. Add a 1/3 to both sides. So 1 is 3 over 3, isn't it? If I add a third, what do I get? I get 4/3. So b equals 4/3. So let's write the equation down. It's going to be y equals the slope, 1/3 x, what? Plus 4/3. All right, and I'll put that in a little box. What's 4/3? 4/3 is 1 1/3, isn't it? Does that look like it hits at 1 1/3? Sure does. We're pretty accurate on this, aren't we? Okay. And the slope is 1/3. All right. Rise 1, 1, 2, 3, run 3. Do you see it? So it all works out nice and neat. So now what do we do with these two? Now that I did all that work, that was really only one step, wasn't it? I did a lot of stuff, but it was basically one step. My step was find the equation of both lines. You with me? What do I do then once I find the equation of both lines? Why did I want to do that in the first place? Well, I wanted to do that because I want to find this x and this y right here. That's what I'm trying to find. And when I use these two equations to solve for x and y, that's going to be your point right here, because that's the point that's in common with both of these lines. Right? So how do I do that? Well, let me give you a little trick. It's not really a trick, but this is what we talked about in the other class. Now, if you remember, when we did the example yesterday, the x's, we used elimination because the x was like a negative x and the other one was a positive x, and they canceled out real nice and easy, didn't they? In this situation, they don't just cancel out real nice and easy, but watch what they are. This negative 3x plus 8 equals what? Y. What does this stuff equal? They both equal the same thing, don't they? So if they both equal the same thing, they're both equal to each other. Exactly right. Did you ever think about doing that? Did you ever do that in Algebra 1? Yeah, in Algebra 1, you probably did that before. That's kind of a nice little trick, isn't it? Look, if they're both equal to y, they're both equal to each other. So up here, where I have a little more room, I'll tell you what, you want to get rid of this just to make it easier to read? So watch, let's set them equal to each other. So it's negative 3x plus 8 equals 1/3 x plus 4/3. Now, what are we going to solve for here? We're going to solve for x. That's right. So let's just do some math and solve for x. Subtract a 1/3 from both sides. Okay? So let's rewrite this, though. Since I'm subtracting a 1/3, let's write that as a negative 9/3. Do you understand why I did that? Because I want a common denominator. So if I'm subtracting something with a third, with a denominator of 3, I'm going to change that so it's 9/3, right? Well, I'm not going to divide it yet. I want to get this x and move it over to this side right now. So this is negative 9/3 x, right? Minus what? 1/3 x. See what I just did? I just subtracted a 1/3 x from both sides is basically what I did. Now, you could do it all kinds of different ways, but this is how I do it. David, you getting all this? You got it? Okay. I know, it's getting a little late. It's a little warm in here. I did turn the air down a little bit, but... All right, so negative 1/3 x. So I'm taking care of that. Now, what do I do with this 8? Subtract an 8. But I'm subtracting it from what? This is over 3. So what would I write this? Let's write this as a, what? We'll just write it 4/3. I'm sorry. I don't know what I'm saying. Hold on just a second. This is 4/3. I'm subtracting an 8, correct? So instead of 8 over 1, I want to put this over 3. So what's that going to be? 24 over 8. You see that? Just adding fractions, right? That's all it is. There's all kinds of different ways you could approach this. That's how I did it. So equals, what's that? What's 4 minus 24? Negative 20 over 3, right? What's this thing right here going to be? It's going to be negative 10 over 3x equals negative 20 over 3. Now watch how nice this works out. How do I get rid of that? Well, actually, they're both going to be positive, right? Get rid of the negatives on both sides. How do I get rid of 10/3? Multiply it by 3/10. So come over here and multiply that by 3/10. So it started looking a little ugly, but now, look, it cleaned up real nice, didn't it? 3's cancel, the 10's cancel. What do we get here? The 3's cancel here. What do we get? Just get a plain old easy 2. All right, after all that mess. Go through it again if you need to on YouTube, right? Stop it, pause it, try it yourself. You just have to get used to doing fractions. And you guys, it just seems historically here, fractions have been our weak part. Okay, so make sure you go through it and understand what I just did there. Now we got to solve for y, and we're close to done. All right, let's put it back into this one. This is the easy one to use, right? It doesn't have any fractions. So let's solve now for y. So y equals negative 3 times 2 plus 8. Negative 6 plus 8 is 2. So where is this point right here? Let's put our grids back up there. I could have just looked at it, but I wasn't sure, right? I wasn't completely positive that was 2, 2, just because I kind of eyeballed where the perpendicular would be. All right, so I know I'm running short on time. I'm going to do this real quick. So what is it? It's 2, 2, right? And now what do we do with the 2, 2? Put it in the distance formula. We can fit it in right here. So can I do this quick? Squared plus squared. What is it? 2 minus negative 1 is 3, right? And 2 minus 1 is 1. That's 9 plus 2. That's square root of 10. Am I right? Yep. Look at that. Finished it.